There is one more thing that you can do here. There is one more extra that you can do here that was not possible in linear regression. It is possible only in logistic regression here. You can do rank ordering of the impactful variables. You first filter out all the impactful variables. Filter out all the impactful variables, or let's say remove all the non-impactful variables, keep all the impactful variables. First do the filtering. After that, you can do rank ordering. What do you mean by that? I have these variables x1, x2, and so on, xk. Out of them, I have removed one or two variables that are not impactful. But out of these 10 variables that I have, which is the most impactful? Top rank. I agree that all these are impactful. Agreed. But what is the top one, top two, second rank, third rank? Is there a measure that will tell us which one has the topmost impact? What is the use of it? Maybe business can start working on it. For example, in our data set, maybe we can tell the business that number of complaints is the top most impactful variable, or maybe relocation is the top most impactful variable, speed test is the top most impactful variable. Maybe if we suggest to our business partners like that, then they may be able to implement strategies, or they may be able to work cleverly so that they can reduce the overall attrition. So that since speed test has the highest impact, anything that I do on this will have huge impact on the target. Yes, all of them are impactful, but rank ordering means what? Out of all the impactful variables, which one is top one, two, three? Like that, can you rank order? So to rank order these variables, you need to look at something called Wald chi-square values. You need to look at Wald chi-square values. In the summary, Wald chi-square values are not given. So for every variable, for x1, calculate the Wald chi-square value. For x2, calculate the Wald chi-square value. If Wald chi-square value is higher, then the variable is impactful. I mean, we can rank order it. It is impactful, but it is top impactful, toply, because we have already considered only variables that are most impactful. So you have to look at the Wald chi-square value for every variable. The higher the Wald chi-square value, the higher the impact of the variable. And the Wald chi-square value is not given in your output. So we have to look at the formula of Wald chi-square value. It is simply z square. Wald chi-square value for a variable is z square. Z values are given in your output. So based on that, you can tell me. What I want you to do right now is look at your output, go to your output. Already you have the variables. These are all impactful, but tell me top one, two, three. One, second most impactful, top most, the third one. What are the three factors, three features that I need to work right now? Tell me, based on the Wald chi-square. What is the Wald chi-square? Z square. Wald chi-square equal to Z square. Tell me the first one, top one, all of you. What is the top most impactful variable? Number one is number of complaints, is it? Let me check that. Spot on, number of complaints. Number of complaints is the topmost one. Number of complaints. Number two, what is the second one? Number two is speed test result. Speed test result. Wald chi-square value is what? Z square. Z square. Z, whether it is positive or negative, doesn't matter. Somehow our human brain has this tendency, whenever we see negative, we think negatively about it. Whenever we see positive, we think positively about it. But we have to leave that tendency when we are building the models, isn't it? A variable might have high impact negatively or positively, it doesn't really matter. It depends on the data, isn't it? Do you agree with me? Whether a variable is negatively impacting or positively impacting, it is none of our business. Whether it is having top impact or not, high impact or not. Maybe high negative impact is also high impact only, like high positive impact. Yes or no? Got it? So be careful. So your next variable is speed test result, which is the second most important variable. Third variable, what is the third variable in this list? What is the third one? Is the relocation. Relocation. So what we can tell in this extra, which was not possible in linear regression, we can not only build the model, we can go back to business and tell, hey, maybe you can work on number of complaints, somehow reduce the number of complaints, then attrition will reduce. Maybe increase the speed test, then attrition will reduce. That's why there is a negative result. Like you increase the speed, then attrition will go down. If speed goes up, attrition will go down. Okay. If number of complaints go down, attrition will also go down. Relocation, that means if people are changing, then there is a lot of attrition in that case. Maybe somehow shifting charges, or maybe build a strategy around shifting, build a strategy around relocation, somehow make it free or something. Then you can reduce the attrition. Like this, we can give some suggestions to the business as well. That doesn't mean rest of the variables are not impactful or anything. The rest of the variables are also impactful, but if you have budget constraints, maybe work on these top three first, then you will see immediate results. Later on you can improve the whole process. That is the overall process of building logistic regression line. Any questions on this?